Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something. Collaborative filtering, first proposed by Amazon and widely used in e-commerce, calculates the similarities between items based on the user's preference for items. It then recommends similar items to the users based on their current preferences. For example, if a person purchases a mobile phone and also buys an iPad, these two items are considered similar. Additionally, when a user searches or browses for iPhones, the system may recommend iPad to them. Regarding the similarity metrics used in
collaborative filtering.
There are various methods employed, and they can be referenced for further information. Let's take a look at an example to help us understand the item-based collaborative filtering. Suppose I'm browsing on Amazon, and I selected a children's fairy tale book about father and sons. When I navigated to the books page in my shopping cart, the recommendation sections below immediately generate the related product recommendations. For instance, it suggests children's clothing and holiday cards with a father-son theme.
This is how item-based collaborative filtering works.
When we view a product, it shows us other items that users have frequently purchased together. So, how is this functionality implemented? Well, its core method is to create a rating table for each item on the platform. This rating table records the aggregated scores of user consumption behaviors associated with each item. When the scores of different dimensions in the rating table of two items are similar, it indicates that these two items are more likely to be purchased together or have a similar level of interest among platform users. Therefore, the system recommends those items to the users. Take a look at this. Here we have a display of rating table. The platform's backend keeps track of 4 aspects of users' data, and each of these 4 behaviors corresponds to a different weight. These weights are calculated by weighting the user's behavior frequencies, and as a result, we obtain the user's score for that particular item. Let's walk you through how item-based collaborative filtering algorithm is computed. Here we have 3 users, these items, and 4 types of behaviors. Here is the recorded user behavior data. For example, in the first row, user A performed a click action on item 1. And in the second row,
user C added the item to the shopping cart.
We can perform statistical aggregations on this backend data to obtain the table on the right. Each cell in the table summarizes all actions performed by a particular user on the specific item, along with the frequencies for each action. From the action table, we can calculate the action scores for each cell. And finally, we can transform and aggregate the backend data to obtain the data table as shown on the right. Let's think about the example we discussed earlier. The users who purchased books on the theme of parent-child relationships are recommended items such as children's clothing and father-child themed holiday cards. The calculations of similarities between these items is based on the overall user rating data on the platform. So far, we have aggregated the rating table. Each shows the rating of different items among all users. If 2 items have similar users' behavior, the distance must be the shortest. Remember, distance measure we introduced earlier, called cosine similarity. Here, it treats items as vector and users as dimensions of the vectors. By calculating the cosine similarities between the two item vectors, we can obtain the distance between them. Ultimately, we can generate a distance table among the items. So, the distance table as shown in the right figure represents the calculation results. This is a symmetric matrix. To get our final recommendation list, we simply multiply the similarity matrix with the rating matrix. The user has already purchased an item recommended for purchase. We can set the corresponding interest in the recommendation list to 0. On the front end of an e-commerce product interface, users will be recommended products with higher weights. Now, let's take a look at the item-based collaborative filtering algorithm. But before we do that, let's quickly summarize what we just learned about the user-based collaborative filtering algorithm. Here, look. The user-based collaborative filtering algorithms primarily consist of 2 steps. The first step is identifying a group of users who share similar interests with target users. The second step is suggesting items to the target user that are liked by the users in this group,
but are unknown to the target user.
And now let's understand what the item-based collaborative filtering algorithms is all about. In this example, let's consider user A, who has interacted with the item A, B, and D, and user B, who has interacted with item A and C. We will use the cosine similarity formulas to calculate the similarity of interest between the user A and user B. User-based collaborative filtering is suitable for a situation where there are more items than users and a strong emphasis on timeless,
such as news or new website.
However, it may have slower calculations and provide less personalized recommendations. On the other hand,
it can achieve cross-domain
and high surprise recommendations, even though the recommendations may be broad in nature. In contrast, item-based collaborative theremin is widely used, especially in the e-commerce industry. It is effective when there are many users and few items, although it may also suffer from slower calculations. It offers higher precision and more personalized recommendations. However, it trends to recommend similar products that users have already purchased, resulting in a lack of diversities and surprise in the recommendations. Users may miss out on discovering new and novel items. To sum it up, in this course, we covered several key topics related to recommendation algorithms. Firstly, we explore the history of recommendation algorithms, providing an overview of their evolution over time. Next, we dived into the collaborative filtering algorithm, which is a popular approach in recommendation system. We discussed how it leveraged the similarities between users or items to make recommendations. We then focused on the item-based collaborative filtering algorithm, which is widely used, especially in the e-commerce industry. These algorithms identify similarities between items to provide personalized recommendations to users. To enhance our understanding, we examined the example of the item-based collaborative filtering algorithm, illustrating its practical applications in real-world scenarios. Lastly, we explored other examples this time of the user-based collaborative filtering algorithm. We observed how it identifies similar users based on their preference to generate personalized recommendations. So that's all about today's course, and we will see you again in the next course.